The other exponent rule that we're going to be looking at today is the quotient of powers rule. In other words, what do we do when we're dividing numbers that have exponents? And so we're going to be looking at that, and that's what we call the quotient of powers rule, which is what we're going to apply to it. So this is the rule, this is what we need to follow. So we've got a to the power of m divided by a to the power of n equals a m minus n. So what does that all mean? Well, a represents the base. So this represents the number that's going to be the base, and the one on top here represents the exponent. So if we have a number divided by another number and they both have exponents, we're going to subtract the exponents. So let's do this with numbers so that we understand a little bit better. So suppose we got 5 to the power of 5 divided by 5 to the power of 3. So the first thing that we need to do before we apply any quotient rule is confirm that we're looking at the same base. In other words, that this number is the same. We can't apply the rule unless the numbers are the same. So in this case, they are. They both have 5 in it. And then we look at the exponents, 5 and 3. So this is going to be the same thing as 5 and 5 minus 3, which is 5 to the power of 2. And now we can solve that. So what this means is 5 times 5. So the power of 2 represents 5 multiplied to itself one time. So it would be the same thing as saying 5 times 5, which is 25. You may have in your calculator a button that looks like this. So you've got the x to the power of y. You want to be using this when we're dealing with exponents. So you would be doing 5, then you would click the button, and that's when it's going to ask you to enter your exponent. You then enter your exponent of 2, and you should get a 25. Now, just as a recap, we need to remember what these exponents actually mean. So remember, an exponent means how many times you're going to multiply the number by itself. So if we have 5 to the power of 3 is the same thing as 5 times 5 times 5. If we have 4 to the power of 4 is the same thing as saying 4 times 4 times 4 times 4. If we've got 8 to the power of 2 is the same thing as 8 times 8. And when using your calculator, like I said, for this question, you would have the 8. Then you would click on this button that has the x to the power of y, and then you enter the exponent. In this case, let's say at 2, and you should end up with a 64. So just a little refresh on what exponents are, what they mean, and what we're actually doing to get our results. Okay, let's look at another example of a division with exponents. So what if we had something like 2 to the power of 6 divided by 2 to the power of 3? Okay, so in order to be able to apply the quotient of powers rule, we need to make sure we have the same base. Do we have the same base? Yes, our base is right here, and they're both a2. So that means we can go ahead and subtract our exponents. The base stays the same, and now we subtract the 3 from the 6, which is the same thing as 2 to the power of 3, which gives us 8. Great. Okay, what if we have something like this? 4 to the power of 6 divided by 4 to the power of 2 times 3. Okay, so for starters, we need to consider two things. Number one, BEDMAS, because that tells us the order of operations. So what are we going to do first when we have a question like this? And the second thing is, where do we apply the quotient of powers rule? So when we look at BEDMAS, we know that exponents come first. See, exponents come before any other type of operation. And so we've got exponents right here. Now, do we have the same base? Yeah, we have the same base. They both have 4. Therefore, we can go ahead and apply the quotient of powers rule, which means that we can subtract our exponents. The base stays the same, and now we subtract our exponents, and we still bring down our times 3 because we're still going to do that as part of the question. We're not going to do it yet until we solve our exponent. Okay, so 6 minus 2 is 4. This means that it's now 4 to the power of 4 times 3. We solve our exponent of 4 to the power of 4, which is 256. And now we can go ahead and finish by multiplying that by 3, which gives us 768. Okay, what about if we had a question like this? 4 to the power of 6 divided by 4 to the power of 2 divided by 2 to the power of 2. Okay, so we said before we actually can apply the quotient of powers rule, we need to make sure we have the same base. So when we look at this question, do we have the same base all across? No, we don't have the same base all across. So we can only apply the rule to this part over here. Okay, well, let's go ahead and do that. So 4 and 6 minus 2 divided by 2 to the power of 2. Okay, we're still going to do that part. It's just not part of our quotient of powers rule. Okay, so we have now 4 to the power of 4 because 6, if you have 6 and you minus 2, you get a 4 divided by 2 to the power of 2. I like to bring everything throughout every single step. Okay, so what is 4 to the power of 4? Well, that gives us 256. Now, divided by, and now we deal with the exponent here, which is 2 to the power of 2, which is 4. Now we can finally divide. Now notice that over here we took care of the exponents on both sides first because in BEDMAS, exponents come first. Now we're dividing, okay? So you don't go ahead and divide this and then apply the exponent. No, we solve for the exponents first. Okay, 256 divided by 4 gives us 64. Okay, let's do one final one. I think we're getting the hang of this. So what if we have 8 to the power of 4 divided by 8 to the power of 2 plus 4. So again, exponents come first because that is our order of operations. And so we look at our exponents and we notice that we have the same base. And so we have the same base, we can apply our quotient of powers rule. Our base stays the same, and now we can subtract our exponents. And we still continue to bring our addition because it's still part of the question. Okay, so we've got 4 minus 2 equals 2, so this becomes 8 to the power of 2 plus 4. We still need to solve for exponents first, okay, because BEDMAS tells us exponents come first. And so let's continue. We're not done solving this, which is 8 to the power of 2, which is 64, plus 4. And all together, now we can add, and we get a 68. So key things to remember. When we are applying the quotient of powers rule, we need to make sure we have the same base in order to be able to subtract our exponents. If you don't have the same base, like in this question right here, you can't apply the rule, okay? You can only apply the rule when you have the same base.